Let's talk about a second example for a nonlinear equation. Where does such a thing come from? Okay, let's say this is the Earth where we are living on, and then we span a rope around the equator, completely tied without any distance. And then we take this rope and extend this rope by 1 extra meter. And then the Earth here, we are lifting that rope, and the question is, how far can we lift? And before starting analyzing the situation, you can guess, is it 50 centimeters? Is it 5 centimeters? Is it 1 meter? Is it 2 meters? Okay, you can think about that it should be at least 50 centimeter because you have 1 extra meter, so 50 centimeters up and 50 centimeters down. And if the rope does not take that shape but this shape, then it should be more than 50 centimeter. But how far is it? Okay, let's analyze here again the Earth, the equator. So here is the midpoint of the Earth. Here is the radius of the Earth. Here is once more the radius of the Earth. And then here we have an angle of 90 degrees, and here again the same. And then this is our extra d. So here we have a length. This is length. How can we describe that length? Okay, if we know this angle x in radian, then this length is r times x. Because if x is 2 pi, then this length is r times 2 pi. And if x is only a fraction of 2 pi, this length is that fraction. So r times x is that length. And this length is r times x plus a half meter. Here also r times x plus a half meter. And what do we have? R is a known. It's the distance here around the equator is 40,000 kilometers. So the radius is 40,000 kilometers divided by 2 pi. And this is the radius in the unit kilometers. Here we had a half in the unit meters, so we should not mix kilometers and meters. If we want to use meters, then we have to multiply by 1000, and then here everything is okay. So what can we analyze in that picture? Not very hard. We can see some equations, and maybe such an equation will help to solve our problem. So what do we see here? A triangle, in here an angle of 90 degrees, and that means this one squared plus this one squared is equal to this one squared, and this one is r plus d, and so we have that equation. What do we have? We have an equation, and we have an r, an x, and a d. So it seems to be 3 unknowns, but that's not true. It's only 2 unknowns, because r is a known, but we kept writing r, but it's that r. But we have 2 unknowns, x and d. 2 unknowns and 1 equation. This is a bad idea. We need 1 more equation. What equation do you see? There are many ideas. Also in the first step, there are many ideas you can have, and a lot ideas are correct ones. Okay, in this video, okay, what can you say? For example, you can say cosine of x is this distance divided by that distance. Okay, so it's r divided by r plus d. Now we have 2 equations with the unknowns x and d, 2 equations, 2 unknowns, that fits. Okay, so we are in the context of a system of nonlinear equations. And how can we solve systems? In the videos following, we first will talk about one equation, one unknown, and after that about two equations, two unknowns, or more equations and more unknowns. And okay, so what can we do? It's often a good idea to have only one equation and one unknown. That's better if it's possible. And in this case, is it possible to reduce the system to one equation? Yes, it is, because this equation here is equivalent to r plus d is r divided by cosine x. And now we can substitute r plus d by that. So we have r squared plus, and now we have our one equation. Okay, so we have one equation, something on the left hand side, something on the right hand side. We can reformulate by a very simple trick to get an equal to 0 equation. And the simple trick is subtract the right hand side from both sides, then it vanishes from the right hand side and we get an equal to 0 equation with one unknown. So we can say this is a function in the unknown x, and we are looking for the roots of this function. The root, or maybe there's more than one root, so the roots of f of x. Okay, what can we analyze in that situation? We can analyze, okay, in this case we know if the angle is chosen to be 0, then what is the result of f? The result is r squared plus 0 plus a quarter, a half to the power of 2 is a quarter, minus r divided by cosine of 0, this is 1. And so we have r squared minus r squared plus a quarter. So we have a quarter, and this is more than 0. So, okay, if we choose x to be a larger value, the largest one possible in this situation is the angle 90 degree, or we are in radian, so pi halved. So let's say f of pi halved, but a little less than pi halved, so let's write it minus epsilon, epsilon a small number, some number, and then what is f of x? It's r squared plus r times pi halved, a little less than pi halved, let's forget that, and minus r divided by cosine of pi halved, a little less than pi halved. What does cosine look like? Okay, so cosine of pi halved minus epsilon is a number very few more than 0, so it's almost 0. So r divided by that is a very large number. Here we have some number, here we have some number, here we have an infinite large number, so this is more or less infinity. So we know the following, that this function here starts, if x is 0, with a quarter, and at pi divided by 2 we have a very low number close to minus infinity, and so it's clear there is a root. That's what we analyzed here. We know there is a root, we know there is a solution. Okay, how can we find this solution? This will be the topic of the videos following. We will talk about bisection, we will talk about Newton's method, we will talk about the secant method, and we will talk about regular falsy. So in this case, I tried to apply all 4 algorithms, and to my own surprise, only bisection was successful. And doing that, we got we get this solution. X is 0.061764. For bisection, we need an initial interval. We have to tell the algorithms, please search in the interval starting from 0, ending at a little less than pi halved. And this interval must be of the kind that on the left-hand side it should be a positive function value, on the right-hand side a negative value, or the other way around, but on one side positive value, on the other side negative value. And then by a simple subdivision, always use the midpoint and checking the function values, you come closer and closer, the interval shrinks, and in the end you get a solution, and the solution is this one. So this is the solution X, but we are not interested in X. What we are interested in is D. So what do we need? We need to come back to this equation. R is a known, D is what we are looking for, X is the unknown, but now the known. So let's reformulate that equation, and we get R minus R divided by cosine X is minus D. And now we can calculate X. If you use that R, if you use that X, you get D to be 121.44, and the unit we used was meters. So that means you can lift the rope by 121 meters. That is a big surprise, at least to me. My intuitive guess was, okay, a little more than 50 centimeters, but these calculations give the answer 120 meters. The first thing is you have to check, is there an error, because this result is very counterintuitive. But if you check, you will see there is no error, and that means that this answer is indeed correct. So this is our example, but let's talk a little about the structure of this function. Okay, if you plot this function here, then you will see that it does not look like that, but it looks like that. And this is the 0.061764. And this structure of the function implies that Newton method, the secant method, regular, falsy, all will fail. So unfortunately, this is a very nasty function. Okay, so this is our situation. Being in a room with students, I ask them, what do you suggest? And instead of suggesting this equation, once a student suggested the following equation from that situation. And the suggestion was tangent of x is rx plus a half divided by r. What is the same as x plus 1 divided by 2r. And now we can formulate tangent x minus x is equal to 0, and we can alternatively look for the roots of that function. And this function is of the following kind. F of 0 is 0 minus 1 divided by 2r, so a value very close to 0, but a negative value. And the derivative of that function is 1 divided by cosine squared minus 1. 1 divided by cosine squared is more than 1, minus 1 is more than 0. So it's a monotonic increasing function, and not of that kind. This is not monotonic, and this is a much more benign equation here, and we can get the solutions with all the algorithms we will talk about in the videos following. Okay, so this was our video. Now I will show you here with the help of Octave. Okay, so let's run that code. We will plot our first function r squared plus r times x plus a half squared minus r divided by cosine x squared. And what do we see? We see this plot. Oh, this plot is horrible. A straight line at level 0. But okay, 10 to the power of 25. Okay, that's a catastrophe. So maybe let's change the axis and run that code. And now we see something, but what do we see? We see here, it's a straight line here, very, very strange. You can think a long time about that, but the answer is use a much higher resolution and plot only on a very narrow part of the interval, not 0 to 1.5, but 0.01. Okay, so if we run that, then we see at least a little bit here the structure of the function. It starts at 1 divided by 4, then it increases, then comes back, and here is the root. Where is that root? I changed the font size, and if we zoom in, we will see this root is at position 0.00617 and so on. If you use the second alternative, and if we run that code, we will see that function, this monotonic increasing function, which turns out to be a much more clever choice. Okay, that's all. That was our video about the rope around the Earth, and I think that maybe you can surprise some people you know by this question. Ask them, let them guess, and then you can surprise them by the answer 121 meters.